We have got a wonderful opportunity to share some nice concepts of the subject. Subject is always beautiful. If you have the heart and mind to enjoy the depth of a subject, it is never ending phenomenon. We can keep on learning, and especially in +1, +2 level, we will be having very few applications. We are only trying to understand what intellectuals have already done. We are nobody to do anything new. We will have to work out on the scientific work which is already done by many intellectual personalities like Thomson, Albert Einstein, Heisenberg, de Broglie, we have got Schrodinger. Many people are there. They have worked so much theoretically and experimentally. So our job is to understand what they could study. We need not discover anything right now that is still there. You can discover later. I advise students to be very inquisitive. Don't feel learning is a burden. Learning is a joyful activity. Through our teaching also we have been learning subjects. The way students understand, the way students give us some nice questions, we also understand many things. We also open up certain cells in the brain so that the student's ideology is appreciated. I think we have got many chapters. I am Mr. Sharma teaching you the chemistry part of it. Actually here we will be teaching with modules, concept wise. It goes on. Every chapter is divided into some modules, and that module is highlighted in the form of a lecture, in the form of PowerPointing, and we can learn do the exercise very easily, all that. Now in chemistry you have got a big syllabus in your standard, and most of you are already familiar with wonderful words like organic chemistry, inorganic chemistry and physical chemistry, some biochemistry and analytical chemistry like. In that actually we have divided that into parts anyhow. Within physical chemistry we first need to learn some aspects which are directly related to physics. As you all know, physics deals with matter and energy, chemistry deals with matter and its composition. Matter and energy, physics, and matter itself is chemistry. You are throwing a ball into the sky, space, it will reach some maximum height and come back due to gravity. That is all phenomenon. Its energy, potential energy, kinetic energy, velocity, momentum, acceleration, time of flight, all these things are physical aspects of a phenomenon involving an object. But chemistry thinks of what? The object is made up of what? Okay, ball you have thrown. Is it an iron ball? Is it a copper ball? Is it a silver ball, gold ball, or a rubber ball, or a plastic ball? So each material has got its own properties. When I said a gold ball is thrown up, you might have smiled like, who will throw? I throw a sodium ball into the sky. By the time it comes back, it will not be sodium. If I throw a gold ball into the sky, gold only will come down if nobody steals it. Gold is a rigid material, noble metal, non-reactive, passive. Gold won't react with air. You throw a sodium ball, it will change its composition many times before it reaches the height. And while coming back, you may not have sodium ball, something else. You may have sodium oxide, sodium carbonate, because air has got moisture. It will react with sodium. Sodium is highly reactive metal. So it will react with moisture of the air, it will react with oxygen of air, sodium oxide, sodium peroxide, which will dissolve in moisture, sodium hydroxide, which is a base, it will react with carbon dioxide, which is an acid in the air. So you may get sodium bicarbonate, sodium carbonate based on the quantity of carbon dioxide present in the air, ppm and all. So by the time it reaches back to your hand, it may not be sodium. So actually chemistry deals with that composition of a material. Plastic is made up of what? Rubber is made up of what? So chemistry is more interested in the matter, its structure. Structure of the matter, constituents of a matter. So chemistry analyzes matter itself, composition. We drink water. Water is made up of what? We run vehicles with petrol, diesel. That is made up of what? Why can't we run a car using water as diesel? I mean, fuel. There are issues, real limitations in the chemistry. Some reactions go on, some reactions do not go on. The entire story is controlled by the composition and reactivity, everything. Especially in chemistry, we deal with major aspects, three. One aspect is structure and composition. Structure, what could be the shapes of molecules, everything. There we deal with structure. The other aspect is the reactivity. Who can react with what? Just now I told, you can burn petrol, you can't burn water. Just ignite, take a matchbox and ignite petrol, a cotton plug dipped in petrol, you ignite, it will burn. You dip cotton plug in water and try to ignite, it will not burn. Some reactions occur, some reactions do not occur. What could be the reason, why it happens, who will react with what? Sulfur dioxide cannot react with carbon dioxide, or sulfur dioxide can react with sodium oxide. Why some react, why some do not react, what could be the reasons? That is reactivity part. And this happens again in organic and inorganic chemistry. So first part is structure part. What is made up of what? What could be the shapes? What are the arrangements of the constituents? Most of you know water. It is made up of water molecules. How hydrogen and oxygen are arranged in water? It is called structure of water molecule. So like that, we deal with arrangements of the constituents. It is called structural part. Second part is reactivity part. Who can react with what? Who will not react with what? What is the reason? What are the limitations? That is reactivity part of chemistry. The third part is still interesting. How much should we react? I want to burn 10 liters of petrol. How much oxygen may be required? I take 10 liters petrol, but I give little oxygen. Will the petrol burn? A part of the petrol will burn. Suppose you keep a candle glowing and keep a dome over it. After some time the candle will stop burning because the oxygen present inside the dome will be over. So still candle is left unburnt. So we analyze by means of various physical factors, quantity, temperature, pressure, volume, density. We do such calculations based on the physical aspects of chemical substances. Somebody says, I have brought some oxygen. That is of no use. That information does not carry anything. How much oxygen you got? 5 liters. What is the pressure of oxygen? 10 atmospheres. At what temperature you have bought? 27 degrees centigrade. Then it is complete. Because it's a gas. Somebody says, I have brought some sugar. That is not a total information. How much sugar you brought? 1 kg, 10 kgs, 1 ton. You know? So like that. So we deal with measurements. That part is called analytical chemistry. Analysis part. So measurement part. The physical aspects. So structure part of chemistry. Reactivity part of chemistry. Analysis part of chemistry. So to understand everything, first of all we must understand matter is made up of what? Matter is made up of what? I said gold, I said sodium, I said water, I said petrol, I said sugar. Many words already I have used. Sugar is made up of what? Petrol is made up of what? Why only it burns? Why the others won't burn like petroleum? Petrol. So all this is really questions to be answered. So what is the most fundamental part of matter? Why gold behaves like gold and sodium behaves like sodium, silver behaves like silver, copper behaves like copper? So that these questions were already there thousands of years. The first name of chemistry is alchemy. So these are the thoughts of alchemists. Few thousands of years ago, chemistry was named as alchemy. Of course, their objectives were different. They want to convert everything into gold. And they want to find an elixir. Elixir means medicine for all diseases. That is where actually chemistry started. People never knew what is the basic fundamental particle, what is the structure and all. They used to treat matter as matter itself. You know. So as recent years, 200 years ago, like that, people were very serious excuse me, about understanding the building blocks of matter. And for our knowledge and for our extension, the best thing was the best history, rather I should say, was known from almost Dalton. You all must be very familiar with this name. He proposed that atom is the most fundamental part of any substance. But atom's existence is not unique. There is no unique atom. There are different elements and every element has its characteristic atoms. Gold is an element. So gold is built up of gold atoms. Sodium is an element. It is made up of sodium atoms. If you take a piece of sodium, don't treat it as a whole. It's a sodium like. You just, as soon as you take a sodium piece, assume you hold a big number of sodium atoms, because atom is a very small entity which you can never visualize. Atom is a very small entity, and atoms of all elements are not alike. Each element has got its own unique natured atom. The hierarchy would be like, suppose you take gold atom, gold material, you cut it into pieces, the pieces are called again gold only. You have a gold piece, see, this is very shiny. gold piece. You cut it into two pieces, again you get this is also gold. Why is it not gold? This is also gold. Again you cut, you will get sodium, you will get gold only. If you keep on dividing this into very small pieces, the best of your visibility, still that can be divided further. And as much as you divide, almost the way you can't visualize it, from there few lakhs of times if you divide, then you will end up with last particle which can never be further divided. It can be divided, but you can't call it gold, and if you divide it, it will lose gold properties. So that last atom, so last particle which still retains the identity of gold, which upon cutting further will lose the identity of gold, is the last least particle, is called the most beautiful word in chemistry or physics, whatever you call it, atom. Such a wonderful word. As soon as you listen that word, you should get a very tiny entity with a definite properties. If you cut it, it loses its properties. Further divisibility is not possible to maintain its identity. Similarly, if you take a sodium piece, again you divide it into so many micro level particles, finally you will end up with one particle. Whether you do it or not, visualize, you will end up with one particle which cannot be further divided. If you divide further, it will lose its properties, and that last particle is called atom. So gold element possesses gold atoms, sodium element possesses sodium atoms, chlorine possesses chlorine atoms, oxygen possesses oxygen atoms, hydrogen possesses hydrogen atoms. Copper, silver, sodium, gold, like that you have many elements. The last particle of this particular element is silver atom. The last particle of this element is copper atom. The last particle of this element is gold atom. For this sodium atom, like that for every element, you have got the least indivisible particle with retaining certain properties, which upon further division will lose the properties of the element, is called atom, the tiniest part of the element. So we can say gold is made up of gold atoms. A wall is made up of bricks. So gold material is made up of gold atoms. Copper material is made up of copper atoms. Sodium material is made up of sodium atoms. So every element is made up of its own atoms. So my dear young students, I advise you to change your vision of subject towards, in a better, higher plane. You have to visualize the things. Once you hold a sodium piece, think that you are holding so many sodium atoms. That is the most aesthetic and creative and innovative method of thinking about an object. You are drinking some water, okay. In general English we say we are drinking some water, but being a chemist, what you should also feel, some water molecules are going into my stomach. That will give you some additional mileage in subjects, you know. So once you hold some sodium piece, why don't you think I am holding a collection of sodium atoms, like that. So one thing is quite sure, materials are made up of very tiny particles called atoms. Atoms of different elements are different in their properties. Of course, they may combine and give molecules, another story, that is chemical bonding. Now, right now in my argument, I conclude that atom is very small. Every element has its own atom. Till in my this 15 minutes lecture, I want my dear students to understand one thing very clearly. The least particle of every element is a characteristic atom. Here what word to be underlined? Characteristic atom. If you cut gold, you will not get sodium atom. You will get gold atom. If you cut silver into micro level division, you will get silver atom. If you cut sodium, you won't get gold. Then we can prepare gold by cutting sodium. Is that possible? Impossible. Sodium gives sodium. So, when you have some silver powder, you can say there are silver atoms. Even if you take one particle of it, that will contain lakhs of atoms. So, atom is very small. Now, what for people who are breaking their heads for about many thousands of years, and to our knowledge for the last 200 years. Thomson and all lived 1850 onwards. Dalton, Thomson, 1800. Later 1900 research was there. Now we are in 2020. Almost complete 1900 and last years of 1800 onwards, 18th century, 19th century. People who are struggling to understand what is there inside an atom. So, what is the drawback? Atom, I don't know, atom is like this or atom is like this, atom may be like this, atom may be like this. Who knows? We don't know how the atom is. So, people who are struggling to understand what could be the structure of an atom, what could be inside an atom, what is the activity inside an atom, many struggles, wonderful approaches, some with experiment, some with visualization. Many things like that went on during almost last 200 years. We have got some data, what people have done. What is the complexity in this issue? The worst part is atom is not visible, and still the worst part is different elements, atoms are behaving differently. That is troubling us. Why gold is behaving like that? Why sodium is behaving like that? Just now I told you, if you throw a gold ball, it will come back as gold ball only. But if you in a deep air on hot sun, if you throw sodium ball, it will not come back as sodium ball. The reason is atomic behavior. So, why the atoms are behaving like that? Why gold atom is rigid? Why sodium atom is so active? Why fluorine atom is still more active? Who is responsible for their behavior? Obviously, something what is present inside the atom. That is the worst part of our query. What is there inside an atom? When atom itself is not visible, what you will see inside the atom? So, our heading itself is very dangerous. What is the heading of our chapter? Atomic structure. Just now I am telling we can't see the atom. Now I am also telling what is the structure of it. The worst part of it is that people have been struggling for the last 200 years. Till today there is no proper conclusion. We can never say I have completed atomic structure. है ना? The complexity itself first you appreciate. If you can appreciate and define your problem properly, you can go towards the solution properly. We want solutions for all problems, but we don't understand the problem. What is the fun? So try to understand the problem first. What is the problem? The problem is I want to know the structure of atom. I don't know what is the structure of atom. What do you mean by structure of atom? What is there inside an atom? How are they arranged? What is the activity? So find it. No, it is not easy. Why? Because atom is invisible. So you are trying to understand the activity of the particles present in an atom which is not visible to you. So what should we do? So some guess, some mathematical approach, some evidential approach. Take certain evidences that atom gives you. So everybody can speak atom is like that, atom is like that. Even I will give atom is something like that. One of the shapes. I will say my atom is like this. Will you accept? No. What answer will satisfy you? You might have heard Niels Bohr. You might have heard Sommerfeld. You heard Rutherford. You heard J.J. Thomson. You have got de Broglie. We have got Heisenberg. No? We have got Schrodinger. Everyone gave some idea about the atom. All are good, but nothing is satisfactory. What makes you feel happy? So for us to accept a particular atom, atomic structure, there should be some reference. Which model will you accept? The model means what? What are the particles of an atom doing inside the atom? So rather activity of the particles present inside the atom, if at all there are some particles. Matter is made up of atoms. Atom is made up of what? After all, atom is nothing but some space in which some particles are distributed. And what are those particles? What is their behavior? So even though atom is small, our discussion is going to be very big. I would like to just put some hierarchy so that you will enjoy. There was a beautiful experiment, discharge tube experiment. This has some experiments really made big revolutionary changes in science. Discharge tube experiment has divided atom into some parts. So suppose if you apply high voltage, very high voltage, keep very few gaseous atoms, extremely low pressure means what? Very few gaseous atoms. Let each atom be exposed to the voltage applied. So atom may be prone for splitting. I said atom. It can be gold atoms, it can be sodium atoms, it can be lithium atoms, it can be hydrogen atoms, lithium, sodium, potassium atoms, cesium atoms, whatever. Discharge tube experiment has brought some revolutionary evidences. Most of you might have studied some cathode rays. some rays passing towards the positive pole. So, definitely the rays must consist of some negative particles. Replace the element. Instead of sodium you keep potassium, you keep hydrogen. Whatever you keep inside the discharge tube, the rays that are projecting towards the cathode, I mean the positive pole, are identical, unique natured. Whether you keep sodium, potassium, rubidium, cesium, hydrogen, lithium, whatever vapor you keep, whatever gas you keep in gaseous form, you apply sufficient potential. And these rays are found to be unique, irrespective of the element. Immediate conclusion is what? Forget about what Thomson said, what Rutherford said, forget. What will you feel? Simple. Sodium is issuing some negative part, potassium is issuing some negative part, rubidium is giving some negative part. All negative parts are alike. Therefore, in an atom, the negative part is made up of the same things, similar particles. In all atoms, I said each element has got its own atom. Gold atom, sodium atom, potassium, rubidium, copper, silver, scandium, titanium, whatever. Every atom is made up of some negative part is there, negative charged part. Cathode rays, negatively charged part is alike. So, there is some content, negative part, but one thing, atom is neutral. Never forget this fact. Atom is a neutral entity. It is neither positive nor negative. So, once you have pulled the negative part out of the atoms, definitely atom must consist of some positive part. Of course, they experimented that also with opposite rays, providing some facilities within the tube, and those rays are positively charged. The positive part of atom, once you are breaking atom into, many atoms may be there in the tube, the negative part of atom is pulled this way, positive part is pulled this way. This experiment has brought revolutionary changes, the observations of this discharge tube experiment. That only has given a path for the discovery of subatomic particles. Atom is made up of what particles? Unique negative particles. The positive rays are not unique. Very interesting. The negative rays are unique. Unique means what? It's fixed, same of character. Whatever may be the substance you use, unique natured. Sodium, potassium, rubidium will give similar cathode rays. But in the anode rays, the positive rays coming out of the atoms are not identical. Of course, I can explain with present knowledge. You all have some knowledge, lithium, sodium have atomic numbers and all. These rays are believed to contain some particles. They are called electrons. Electrons are unique from wherever they come. Will you find a difference between this electron has come sodium, this electron has come from calcium, like? No. All electrons are electrons. That uniqueness was revealed by this small beautiful experiment. That E by m ratio, we call it E by m, charge by mass ratio. How much charge has come, how much mass has come, the charge by mass is same irrespective of element. lithium, sodium, potassium, rubidium, calcium, hydrogen. The charge of the rays by mass of the rays is same. So, the best conclusion from the small, beautiful, simple outcome from a great experiment is every atom consists of some negatively charged particles called electrons. If you remove those electrons, the rest of the part of the atom need not be same. Suppose right now we have some knowledge, lithium, sodium. If you remove electron from this, that is lithium plus. If you remove electron from this, that is sodium plus. Why should sodium plus and lithium plus be same? They are positively charged part of atom. They need not be same. Its mass is not same. Charge may be same. Their E is same, but M is not same. How will lithium ion, sodium ion have same mass? So, these rays are not unique. So, people who are making some other conclusions out of it. So, in anyway, once electrons are there which are negatively charged particles, of course, based on their deflection and all, based on the pole towards which they are moving, we can easily conclude that negatively charged particles. Once negatively charged particles are there, there must be positively charged particles inside an atom. Of course, they also were analyzed by means of these anode rays, and equal charged particles are found, that they are called protons. They are negatively charged, they are positively charged. Of course, that mass is not matching in every case. So, later some other experiments by Chadwick proved there are some other particles which without charge and with little mass, they are called as neutrons. These three are the godly particles, fundamental particles which build up an atom. Atom is made up of electrons, protons, neutrons, and the uniqueness of each atom, each of an element, is based on the number of atoms, number of electrons, number of protons, number of neutrons. Why gold is gold, sodium is sodium? Because they differ in the number of electrons present in a neutral atom. That is where they differ. To that conclusion, people have come very fast, quickly, in the early days, somewhere around 1900. That okay, number wise people are happy, but activity wise there was always a $1 million question. So, what great achievement we could appreciate out of this discharge tube experiment? Discovery of electrons, discovery of protons, and with some nuclear transmutations, discovery of neutrons was done, and these three are called the fundamental particles of an atom. An atom consists of some other variety of particles also. There are some other particles. We have positrons, and we have got quarks, we have got pi mesons, we have got positrons, I told you, and even an atom may consist of some beta particles, electrons inside a neutron. We have got some other big story we will discuss. Right now you appreciate an atom is made up of electrons, protons, neutrons, and these are obtained from this. Now, so we are pretty sure this is atom. I don't know the shape also. I just put a circle, I mean sphere. So there are electrons, there are protons, there are neutrons. What is the charge of an electron? See, Thomson could get E by m, uniqueness of E by m, irrespective of the element. Whatever element you take in the discharge tube, E by m of cathode rays is unique. The charge by mass is unique. So, you have got some value for it, fixed value. Later, there is still appreciated experiment was done by Mulliken oil drop experiment. That is based on, they charged an oil drop, I mean oil drops keep falling and each oil drop is charged, and charged oil drop movement is prevented by applying a magnetic field, and matching the magnetic field strength and electric field strength and the movement of the particle, people could realize the charge present on the oil drop. Suppose this is an oil drop, there is some negative charge present on it. This negative charge accumulated on that particular oil drop, not only single drop, there can be repeated experiments. This charge is always found to be a whole number multiple of one particular value. So, n into some x is the charge. Remove this oil drop, charge one more oil drop, that will also take some charge on it. That charge is also the whole number multiple of x. So, once you charge a particle, once you charge an object, the charge accumulated on the object is always, even today you charge something, the quantity of charge accumulated on a body is always a whole number multiple of some fixed value. The charge can be obtained from that classical physics, equalizing the magnetic field and electric field and the movement of the particle, that is a different story. But conclusion of Mulliken oil drop experiment is important for us. The conclusion is, once you charge any body, the quantity of charge accumulated on that particular body will be always a whole number multiple of some fixed value. What do you understand? Some n into 1.602 into 10 to the power of minus 19 coulombs. This n can vary, it can be 1 lakh, it can be 2 lakhs, it can be 10 lakhs, it can be 100, it can be 1, but it will be always a multiple of this. What do you conclude? We can simply understand that this particular charge is because of accumulation of some particular particle carrying this much charge, and the negative charge is always caused by what? Electrons. There is nothing in this universe which causes negative charge other than electron. You see chloride, who is responsible for that negative charge? Electron. You take sulfate, who is responsible for this negative charge? Electron. Once you see negative charge in the earth and heavens, it is because of electron. Excess electron may make one particular object negatively charged. So, definitely the particle is charged by electrons, particle is charged by electrons. So, this charge is always multiplying, extent of charging may be different, but it is always a whole number multiple of this. Means what do you understand? This is the charge of one electron. So, the oil drop may have 2 electrons, 10 electrons, 100 electrons, 1000 electrons, 1800 electrons, it is always that n. So, once you see a charge q, that will always be a whole number multiple of this, and we understand there must be some particle which has got this much charge, and it is a negative charge. So, we understand this must be the charge of one electron. Excellent. We understand charge of one electron, negative 1.602 into 10 to the power of minus 19 coulombs. And we know E by m of electron, charge by mass. Charge by mass of cathode rays is proportional to charge by mass of electron, because cathode rays are made up of electrons. Let there be 100 electrons. So, 100 into that charge, let there be 100 into that much mass, 100 cancel. So, charge of cathode rays by mass of cathode rays is nothing but charge of one electron by mass of one electron. Keep it in mind. So, hats off to Thomson. Hats off to Thomson. He gave us E by m of electron. Hats off to Mulliken. He gave a charge of electron. Now, can't you get mass of electron? This by that. This is an experimentally verified value. This is an experimentally obtained value. This is from cathode ray experiment. This is from Mulliken oil drop experiment. So, they are evidential. No one can question. There is an experimental evidence. So, this is charge of electron, specific charge of electron, charge of electron per unit mass. Now, I know this value, I know this value. If I divide, what will I get? E by m gives me m. I can get mass of electron. Hats off to J.J. Thomson, hats off to Mulliken. We could get some evidence for the presence of some fundamental particles in an atom. And pretty sure now, common sense, once there are electrons present in an atom, electrons being negatively charged, atom being neutral, so there must be positively charged particles present in an atom, and they are found to be protons. So, a proton is another particle, fundamental particle of an atom, which are obtained from the anode rays, which contains the same charge that of electron, but mass is not same. E by m of a proton is pretty low value compared to E by m of electron. Charge of electron and charge of proton are same, but mass of proton is much higher compared to mass of electron. So, charge by m of electron is much greater than charge by m of proton. Why? Charges must be same, masses are not same. So, proton charge, electron charge are same. Proton mass is much higher than electron, somewhere around 1837 times heavier, that we will see later. So, E by m of proton is much less, E by m of electron is more. And there is yet another particle called neutron, that was proposed by Chadwick, that does not carry any charge, but it carries a mass, or vice versa. You can write 1 on the top, 0 here. it does not carry any charge, it carries only mass. That is a unit, but it is not the absolute value. I will tell the absolute values. So, let us appreciate Thomson, let us appreciate Mulliken, let us appreciate oil drop experiment, let us appreciate discharge tube experiment, and thanks for them that we could make some progress in structure of atom, saying that atom is made up of mainly electrons, protons and neutrons. So, we got this conclusion. How many? Some n electrons, some n protons. Of course, this n is different, this n is different. Number of electrons and protons must be same, so that the atom remains neutral. Electrons are negatively charged, protons are positively charged, and the net charge on each electron and each proton are same, minus 1.602 into 10 to the power of minus 19 coulombs. Proton is plus 1.602 into 10 to the power of minus 19 coulombs. They differ only in the charge, type of charge. So, if you have n number of electrons, there must be n number of protons, and that number is called atomic number. Why sodium is like that? Why magnesium is like that? Sodium's atomic number is 11, magnesium atomic number is 12. So, they differ in their properties, they differ in their atomic structure. Still the question is haunting in my mind, what is the structure of atom? First of all, we should be clear in our problem. What is our problem? What are these three fellows doing inside an atom? What is the activity of the subatomic particles inside an atom? So, to know that, first we should know their nature. We could get them almost by Thomson, Chadwick and Goldstein, like that. So, first let us go through their details once, so that we can appreciate. The best evidence of atom made up of some elementary particle, discharge tube experiments. Elementary particles are what? Electrons, protons and neutrons. The negatively charged particles of cathode rays are electrons. Protons were discovered by anode rays. The neutrons were produced bombardment of beryllium with helium. This is called a nuclear reaction, it is not a chemical reaction. What is nucleus and all we will see. So, beryllium bombarded with alpha particle produced carbon, then a neutron is released. Mass is 1, charge is 0. So, this is the fundamental data about electrons, protons and neutrons, and you must be very familiar with them, just like how you speak your name. So, you should speak these things should become a part of your life. Electron mass 9.1 into 10 power minus 31 kgs or 10 power minus 28 grams. Charge of electron, you see, two varieties of units are given. The first one is SI unit, the second one is CGS unit. We make measurements in two different systems. In one system we use SI units, the second system is CGS. In CGS units of charge is electrostatic units. 4.8 into 10 to the power of minus 10 electrostatic units, the charge of electron. Just remember, just like your name. Will you forget your name? I say. So, like that you should remember this. And in coulombs, 1.6 into 10 to the power of minus 19 coulombs. About proton, 1.6 into 10 power minus 19 coulombs, and the charge is 4.8 into 10 power minus 10. See, did you observe this? The magnitude is same, but sign is different, opposite charges. These cause positive charge to an atom, these cause negative charge to an atom. Neutron has no charge at all. And coming to the mass of electron is 9.1 into 10 power minus 31 kgs, very low. See, mass of proton 1.672 into 10 to the power of minus 27 kgs, minus 31 kgs, that is minus 27 kgs, very heavy. That by this gives you somewhere around 1837 or something like that, approximately 1800 times heavier. Which one? A proton. Neutron is slightly heavier than almost same, because the power is minus, you can say that almost same, 1.67 to 10 power minus 27, 1.675 closely. There are some other numbers there. There is a fractional difference between masses of protons and neutrons, but there is a large difference in the mass between electron and proton. I advise all the students to make a note of this table. Of course, it is available any source. More than that, you should keep it in mind. Charge of electron proton are opposite, same. Mass of neutron proton close, mass of electron is almost negligible compared to this. Individually it has got some micro level mass. Now I started my lecture like why gold is different than sodium. They have their unique atoms. Every atom has got a characteristic number of electrons and protons together. Whatever may be the number of protons, must be the same number of electrons be present. Sodium possesses 11 electrons and 11 protons. This is sodium. It has 11 electrons and 11 protons. There may be some neutrons also, let it be there. Sodium atom is neutral because of equal number of electrons and protons. As long as it is neutral, the number must be same, and this number 11 is called Z, atomic number. Atomic number of sodium is 11, atomic number of magnesium 12, aluminum 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17, like that, argon, potassium, calcium. Every atom is identified by a unique atomic number which represents the number of protons present in it, number of electrons present in it, which are equal in number. Otherwise the atom gets a charge. If there is an imbalance in this number, it will be either positively charged or it will be negatively charged. This is what I was speaking, E by M ratio. So electrons E by M is very high, protons than protons. Neutron has 0 E by M because neutron has no charge at all. It has got only mass. Atomic number Z is equal to what? The number of protons. Obviously number of electrons be same because atom is neutral. Now we have got a mass number defined. I didn't speak anything about neutrons while telling you atomic number Z. An atom is made up of some number of electrons, some x number of electrons, x number of protons, some y number of neutrons. And who contribute mass to this atom? Protons and neutrons. So their net number put together, that number is called mass number. denoted by A. Number of protons plus number of neutrons. So, X plus Y is called mass number. Every atom possesses some protons, some neutrons contributing to the mass. So, we call it mass number. The mass number may vary for the same element also. I have got some varieties of carbons in nature, varieties of hydrogens in nature. So, once you want to show an atom like this, you must show the atomic number here, you must show the mass number here. This represents number of protons, this represents number of protons plus number of neutrons together. So, obviously, if you subtract this from this, what will you get? This is number of protons and neutrons together, this is only number of protons. So, obviously, this gives me number of neutrons. Of course, the number of neutrons does not influence the chemical properties of an atom. Properties of an atom simply depend on the number of electrons in a neutral atom. So, let us see. Suppose I said I have got varieties of hydrogens. Some hydrogens may, all the hydrogens contain one proton only atoms. Once there is only one proton only, you should call it hydrogen. An atom is named on the basis of the number of protons present in the atom. And what about the mass numbers? The mass number 1 hydrogen is available in nature, mass number 2 hydrogen is available in nature, mass number 3 is available in nature around us. Even if you drink water, that will contain all the 3 with different ratios. Almost this will be 99.98% in nature. If you drink some water, out of the molecules what you swallowed, 99.98% of the molecules contain H11 only. This is almost 0.02, not exactly. This will be pretty less. For every one part of this, you will have 10 power minus 17 parts per 1 part of hydrogen. Means what? If you have 10 power 17 hydrogen atoms, just one atom will be there, H13. That is a different story. Statistically, we will see later. First, you appreciate it. Hydrogen means not simply hydrogen. Hydrogen can have 3 varieties, differing in the mass numbers. If the mass numbers are different, means what? No way protons and electrons can be differed. Once one electron is there, one proton must be there. But here their mass number is 2 means what? Its atomic number 1 means 1 proton, so 1 electron, 1 neutron, sorry 1 proton, 1 electron. So, why there is 2? There is one more neutron present in it. So, 2 minus 1 number of neutron, there is 1 neutron, there is no neutron. 3 minus 1, 2 neutrons. So, A minus Z number of neutrons, and these are called isotopes. Isotopes. Excuse me. Atoms of the same element having different mass numbers are known as isotopes. See, just now I showed H11, H12, H13. Their Z value is same 1, 1, 1, but their A values are different 1, 2 and 3. So, number of neutrons are different. You have carbon 13, you have carbon 14. Both are carbons only because the atomic number is 6. So, oxygen 16, oxygen 18, you have got nitrogen 13, nitrogen 14. You will have different mass numbers. Now, there is an interesting thing what you should learn. Suppose we say, I said carbon's atomic, carbon 12 is there, carbon 13 is there, carbon 14 is there, like this. Then what is the mass of carbon element? Mass number of carbons, atomic weight of carbon is what? Should we take it as 12? Should we take it as 13 or should we take it as 14? Somebody asks what is the atomic weight of carbon? Mostly you put 12. Calcium carbonate, what is the molecular weight? You are taking that carbon as almost 12, but there is 12, 13, 14. There is no mention in that. So what is the atomic number of atomic weight of carbon? Actually you have to take the weighted average of this according to their abundance. Suppose in nature these three are present, they are distributed like that. If you collect some carbon dioxide, that will have some percentage of this, some percentage of this, some percentage of this, is a natural distribution. So this is X percent, this is Y percent, this is Z percent available in nature. So based on their availability, we have to decide the average atomic weight. So all put together you will get 100. So X into 12 plus Y into 13 plus Z into 14 divided by 100 is the atomic weight. Atomic weight of carbon. That is actually how we calculate. So we have got some isotopes like that. Many isotopes may be there for each element. Anyhow, that is a deviation from our present topic. Our focus is what? We should understand the hierarchy of various works done by different number of scientists who supported us to understand, at least move close to understand what is there inside an atom, which is not visible with naked eye. So knowing the structure of atom is like searching for a black cat in a dark room which is not there. The room is dark, there is a cat, cat is black in color, you are trying to search for it. It is knowing the atomic structure is almost like that. So that hierarchy which took almost 150 years, we should try to understand in few classes. So we will work out with 100% logic, with lot of interest and enthusiasm. So I advise all the students to listen the hierarchy in a continuous manner, because everything is linked to some other thing. Thomson is linked to Rutherford, Rutherford linked to Bohr, Bohr linked to Sommerfeld, linked to somebody else, de Broglie. That linking, hierarchy you must understand. What are the limitations of previous scientists and how we achieve some advancement. That scientific logic we will have to work out carefully. So I advise students to be very continuous in their listening the classes. Enjoy, have a good day. If you have any doubts, just go through recorded version. Enjoy, we will meet in our next session. Till then, have a good day, enjoy.